Okay, I'm reviewing the question that you had on your lesson quiz, which was problem number 49. And I'm just reviewing this because it had radicals on it. Didn't realize that that was on there, and we didn't take notes on it. So if you'd like to add this to your notes to help you for the review has 2 of them, so that's a good practice for you to make sure that you know how to do this. Some people converted their radicals to decimals, which you can, as long as you're keeping track of the long decimals that you've got. Okay, I'm going to do it with radicals just because our next section has radicals, and you need to be recalling from last year what it is that we do with radicals and how we treat them when we're combining them, as adding them, multiplying them, squaring them, and all that kind of stuff. Okay, so question number, I think I said at 49, it's 69. So question number 69 on the lesson quiz said, find the area of kite ABCD if BD is 2 rad 3, AD is 2 rad 3, and DC is rad 6. And then the only other thing it said is the kite is not drawn to scale. Round your answer to the nearest tenth. Okay, so I just sketched up here. Again, pause this video if you need to make sure that you're understanding, and maybe rewind it if you need to. Okay, so these were the key things that they had in the sentences. Okay, so I just drew my kite, and I labeled what they gave me. So BD was the diagonal that went across here, which was 2 rad 3. And then the other 2 things weren't diagonals, they were actually the sides. Okay, so in order for us to find area, we're taking the diagonal, one of the diagonals, and the other diagonal, and we're multiplying them together and then dividing by 2. Well, right now, all I know is one of the diagonals. I just know this one. Okay, so we're going to do the same thing that you've had in your notes, where we're going to have to find the diagonal that goes across here. So by doing that, we create right triangles. Okay, so when I draw a line that goes across, okay, my original one, so I'll just do it in a different color. Okay, I have my one diagonal, but I need to find this diagonal that goes across here. So there's part, and then we have to do another one that's going to be part here, so that we can find that total diagonal that goes across. Okay, so I drew a right triangle for you. Okay, here. So if I'm just looking at this part right here, so I can solve for this side. Okay, all I have right now is rad 6 because the 2 rad 3 goes across all the way. So I need to find out what just this is right here so that I can use it to solve for the height. So that means I need to divide it in half. So we've had some, like say DB was 8. Then I would know from here to halfway would be 4 because I would divide 8 in half. Okay, well, doing the same thing with radicals, now you just need to recall what you know about radicals. Okay, so if I had 2 rad 3 divided by 2, I could cross off my 2's, right? Because 2 divided by 2 is 1, so they just cross each other off. So all that would be left here is rad 3. Okay, so if you recall, this is not this problem, but if you recall, if we have a right triangle, if I have a right triangle and I have this number and this number, one of those is an A or a B and the other one is a C. So the longest side is my C. Okay, so that means that this one is going to be my C, and then this one is going to be either my A or B. Okay, so I put it in the equation as an A. Okay, so I have rad 3, okay, that I need to square. Okay, so that's rad 3 times rad 3, and rad 3 times rad 3 is rad 9, and the square root of 9 is 3. Okay, so I simplified that down to right there. Okay, well, we don't have the answer for the b squared yet. So now I need to square my c. Okay, so this one was my c, so I'm going to do the same thing. So I'm going to go rad 6 times rad 6, which is rad 36, and the square root of 36 is 6. Okay, so now we're at this point where I've got to get the b squared by itself, so I subtract 3 over to the other side. Okay, so now I have b squared equals 3. So to get the b by itself, I have to take the square root. And what I do to one side, I've got to do the other side. So remember, the square root gets rid of the square to get the b by itself. Okay, but then I still have the square root of 3. Okay, so that means that just because this gets rid of this, this is still there, okay? Because we cannot take the square root of 3. So this number right here is the height of the triangle that we just had. Okay, so if I take this back up here, now I've got the height. So it's just going to be rad 3. Okay, so that's one of our diagonals. Now I need to figure out what my other diagonal is. So the one that I just found, if we go back to our original drawing, is this one right here. Okay, so that is rad 3. So now I need to find the height of this one here. Okay, well, we already found out what the half of 2 rad 3 is. Okay, so we've already saved some time, but now we need to square this guy. Okay, so this is my drawing right here. Okay, so we already know that 2 rad 3, because we already did it over here. So 2 rad 3 divided by 2, we crossed out the 2's, and you just have rad 3. So there's a rad 3 right here, but then we have 2 rad 3 as my C. Okay, so when I square rad 3 times rad 3 is rad 9, right? We already did that over here with this problem. So I know all of that's going to simplify down to 3. Okay, then I have my b squared, bring that down. Okay, so now I need to square my c, which was 2 rad 3. So I'm going 2 rad 3 times 2 rad 3. Okay, whole number times whole number. So 2 times 2 would give me 4. Radical times radical, so rad 3 times rad 3 would give me rad 9. Well, the square root of 9 is a perfect square. So anytime you have a perfect square and the radical's not there, if you have a number on the outside, you got to times it by it. So the square root of 9 is 3, right? So that means the radical goes away because the square root of 9 is a perfect square, which is 3. So now you're just going to times those two numbers together. So 4 times 3 would give you 12. Okay, so now we're at this point. Okay, so now I have 3 plus b squared equals 12. So now we're doing the same thing that we did over here. I've got to subtract my 3 over. Okay, so I have b squared equals 9. Well, b squared, right? Take the square root of this side, square root of this side. This is actually a perfect square. Okay, so the square root of 9 is 3. So that means my b is 3, because you can take the perfect square of that. Where over here we have a square root of 3, right? And that's not a perfect square. So now I have my other height. Okay? So now we just need to put the two of them together, because I had, let me go back up here on our drawing. Okay, this is rad 3, and this is actually a perfect number, not a radical, and it's 3. So now we need to talk about how we combine these. Okay, so I drew the drawing here. Okay, so we know going across here was 2 rad 3 at the very beginning. We solved for this one, and it was rad 3, and we solved for this one, which is 3. If this was 3 and this was 4, you would be adding them together to get 7, right, to find the total distance. Well, because one of these is a whole number and the other one is a radical, it's kind of like adding a whole number to a variable. You can't do that unless they're like terms, okay? So we're just going to leave it as an addition problem, okay? So it's right over here. So I know that I'm supposed to add rad 3 and 3 to get the total thing for the distance, okay? And then here is my other diagonal. So we know we're supposed to take up one of our diagonals, okay, that one right there, and multiply it times our other diagonal. Well, I don't know what they are because I can't combine them because they're not like terms, okay? So now you need to distribute. Okay, whole number with whole number, radical with radical. So 2, and this is really a 1 that's right here, so 2 times 1 is going to be 2. And then rad 3 times rad 3 is rad 9. But remember, if it's a perfect square, it comes out. So the square root of 9 is actually 3. So 2 times 3 is going to give you 6. Okay, now we do it again. So this is 2 times 3, which is whole number times whole number, right? Which is 6. And then rad 3, when it goes here, there's not another radical, so it just stays the same. Okay, it's similar to having like 2x times 3. If I multiply that, that's going to be 6x. Okay, it's just we don't have an x, we have a radical. Okay, you can only combine radicals with radicals or x's with x's. Okay, so we read from our numerator as far as we can go. We can't combine them because one has an x, the other one doesn't. One has a radical, the other one doesn't. So now you're just dividing. So 2 goes into 6 3 times. And then 2 goes into this 6 3 times, and you just leave the radical alone. Okay, so you can leave it like this because this is similar to having something like this. Okay, you can't combine them because one has an x and the other one doesn't. Okay, so you just leave it. So some of you multiplied it out and found out what the radical of 3 was, times it by 3, and then added 3, and you would get a decimal. Okay, but I want you to start practicing what you do with radicals and how you write it, because our next section is going to be involving that. So this was the actual answer on the lesson quiz. So those of you that were here yesterday, we graded it. I gave you extra credit if you got it right. If you didn't, it didn't count against you, but it will be 2 problems on the review that are like this. So you need to give it a shot, okay, for us to be prepared for the test. If you need any help, 4th period I'm going to be here. I'm going to be here tomorrow all the way until noon, and in the afternoon I'm going to be gone. So, but you're not going to have a test until the next day. So if you need to come in and ask me questions about that, make sure you do so before you have your test. Okay, good luck.